Okay, come, let's look at some sample questions of electricity. So Tiffany conducted an experiment using identical bulbs and batteries, very important, all right? Same, no variation here, with the setups below. And then the light sensor is used to measure the brightness, okay, of the thing. So there's just the bulb, there'll be brightness, there's brightness, there's light sensor, setup P, setup Q. So the key different variable is that there is a white card at the back and the light sensor is in front. So fill in the boxes below with P or Q to show Tiffany's results. Okay, so which one will be brighter? The one that's brighter is actually Q, and the one that's less bright is actually P. And the reason is because the card reflects the light into the light sensor. Alright, so that's the reason behind it. That's how you explain, because the white card reflects the light, part of the light, into the light sensor. So in another setup R, Tiffany connected another identical bulb in series to the bulb in setup Q. So let's look at setup Q again. So in series, so therefore there is another bulb in series, and then it goes back to the switch. Alright, looks like this. So what will be the reading on the light sensor? So the reading, it will be, as compared to setup Q, it will be dimmer as compared to setup Q, because less current is flowing through the bulbs as they are connected in series. Okay, so based on my notes just now in the previous video, you should know that when I connect two bulbs in series, there will be lesser current going through each of the bulb, and that's why it will be dimmer. All right, so the way to avoid this dimming effect is actually to connect the bulbs in parallel like this. Okay, so if you connect in parallel, the bulbs will be the same brightness. If you connect in series, it will be less bright because there's less current flowing through. Okay, so let's look at this question. The circuit below consists of 4 similar batteries, 4 similar bulbs, and 4 bars W, X, Y, Z, which are made of different materials. So even just looking at this, right, I know there's bars W, X, Y, Z, or Z. I know that this kind of question is usually testing if for conductors or insulators. Okay, so this kind of questions, usually they will say, oh, W, so there'll be some bulbs that are lighted up, which one is a conductor, which one is an insulator. So let's take a look. So which one of the following classifications of the 4 materials is correct if only one bulb in the circuit is lit? Alright, so there will be some conductors and there will be some non-conductors, which is also known as insulators. Okay, so let's take a look at this. Conductors of electricity, X and Z. X is a conductor, Z is a conductor, I is an insulator, this is an insulator. So what's going to happen? So you can actually cross this out. So you can draw the circuit, go here, cross out, alright, means stop, doesn't go anywhere. The circuit, go here, conductor means yes, come here means this is a lighted up, come down here, come here, cross, nope, come down here, yes, lighted up, battery, yes, it will go through and it will come back. So there will be 2 bulbs that are lighted up. So I only want 1 bulb, so therefore this is wrong. So in order to save time, you need to analyze the circuit first. So you need to realize that this row and this row, these 3 rows are in parallel. All right, and these two are in series. So if I just want one bulb to light up, therefore I need this. This is the only one with one bulb over here. So I need this to be a conductor, and the electricity will then flow here. And I need this to be a conductor, then it will flow back here and close, and this bulb will light up. But I need these two to be insulators, so that when my electricity goes up and comes up, it will be stopped here, goes up and comes up, it will be stopped here. And then these three bulbs will not light up. So let's take a look. Means therefore I need my Y and Z to be conductors, which is over here. All right, conductors is Y and Z, and my non-conductors is W and X. So my answer is 3. Okay, so study this diagram carefully. If one bulb fused, the rest remains light up. Which bulb is fused? So therefore, if once I see one bulb fused and the rest light up, right, I know that the bulb is in a parallel circuit with the rest. So this A and CD are in parallel, but B is in series with the rest. So if my electricity come here, if bulb B fuses, everything will not light up. All right, so bulb B must be there. And if let's say bulb A fuses, it will be blocked. All right, but then the electricity can travel in this direction, go to D, go to C, and come back. So that's okay. Now, if bulb D fuses, so what happens? My electricity goes here, it's okay, and it will go and come back. All right, so that's one bulb. Then it will come here as well, come here and stop here. Right, and then bulb C will also not light up if bulb D fuses. So therefore, the answer must be A. So let's take a look at this question. Usual setup an electric circuit as shown below. A, B, C, D are objects made of different materials and placed in a circuit. When the switch is closed, certain bulbs light up. So again, when you see different materials, you're talking about conductors, you're talking about insulators. Alright, so when the switch is closed, he recorded the bulbs that lighted up in the table. Bulb B1, B2, B3, B4. Yes, no, yes, yes. So you need to draw this in the diagram. B1 is yes. B2 is no. B3 is yes. B4 is yes. So just looking at the diagram, let's try and analyze and see which are conductors and insulators. So the battery electricity will come out here. So this one is lighted, right? So therefore, the electricity must come here and here to here to here to here. So this must be a conductor. This must be a conductor. Now this is not lighted up, so the electricity will come here. This is a question mark yet first, and then I will come here. But I know that this is not lighted up, so electricity stops here. But these two are lighted up, so I know that this is a conductor. And then it will come here and come back and go all the way up. Okay. Now, if these two are also not lighted up, therefore this is also a insulator. All right. But now since it's lighted up, so we know that that is not correct. So let's look at what are the conductors. So the conductors are A, C, and D, and the insulators are B. So let's check out the answer. So B is the insulator, A, C, D are the conductors. So conductors, conductors, conductors. Therefore, the answer is 1. Okay, let's look at this. Identical bulbs and batteries were used in the circuit diagram below. Switch are then closed. What happens to B2 and B3 when B1 fuse? So B1 is no more. So let's draw the path. This is closed. So let's go down. It will go through and it will stop here. All right. It's open circuit, so therefore B2 is not lighted up. This one will go. It will go through. Switch is closed. It will come back, and it will go back. So therefore B3 will be lighted up. So B2 will be dark, and B3 will be lighted up. Okay, so explain your answer in C1, which is this answer. Why is B2 dark? Because B1 and B2 are connected in series, but B3 is connected in parallel. Alright, so this guy Moody made 4 electrical circuits using similar batteries and bulbs. So 2 batteries, 2 bulbs, 1 battery, 3 bulbs, 2 batteries, 3 bulbs, 2 batteries, 1 bulb. Alright, so he used a light sensor to measure the brightness in each of the bulbs, blah 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 blah. The graph showed the thing. Okay, so let's rank them first. So we'll rank from the brightest to the dimmest. Okay, so brightest will be the most battery with the least bulbs. Dimmest will be the least battery with the most bulbs. Okay, so let's find the most battery. So I have this one, 2 batteries, 2 batteries, 2 batteries with the least bulbs. This has 2 bulbs, this has 3 bulbs, this has 1 bulb. So therefore, this is number 1. Okay, this is the brightest. And then 2 batteries with 2 bulbs will be number 2. 2 batteries with 3 bulbs will be number 3. 1 battery, least battery with the most bulbs will be number 4. Okay, so this is brightest to dimmest. Brightest to dimmest, 1. Wait a minute. Brightest to dimmest is U, number 1. Number 2 is R. U, R. Number 3 is T. T. And number 4 is S. Alright. So they want dimmest to brightest. So A, B, C, D. So dimmest to brightest is S, T, R, U. So I look for S, T, R, U. So the answer is number 3. Now it's important to draw this line down because it's very easy to get confused. Are you ranking from brightest first or dimmest first? So when you draw a line down, you know that the upper part is the brightest and this is the dimmest. Okay, so you can even write brightest and dimmest. Or if you want to rank from dimmest to brightest, then you do this, dimmest to brightest. Then you can write down the letters over here and it will be much clearer to you how you are ranking them. Okay, so let's take a look at this question. Ming Ming set up an electrical circuit as shown below. Which bulbs will be lighted up when all the switches in the circuit above are closed and bulb Z has fused? So all the switches are closed and bulb Z has fused. So let's take a look. Let's draw the electrical diagram. So it will come here, it will come down, it will split, come here, go here, come up, and come in. So bulb X will be lighted up, bulb W will be lighted up. So all the switches are closed, it will come here, bulb Y, and it will be a closed circuit. So bulb Y will be lighted up, come here, and bulb Z has fused, so bulb Z will be not light up. So therefore it's W, X, and Y. W, X, and Y. Okay, so given that all the bulbs are working, what is the greatest number of bulbs that can light up when any 2 of the switches S1, S2, and S3 are closed? So any 2 are closed. So let's check this out. So let's say S1 and S2 are closed. So let's draw it. So that's two bulbs. That's another 1 bulb. So this is open. So therefore, nope. So that's 3 bulbs. So S1 plus S2, you get 3. So let's try S2 plus S3. So S2 plus S3, what do you get? No more. So you get this one, this one, this one, this one, this one, this one. So you get 1 and you get 3. You get 3 bulbs as well. So what about S1 plus S3? How many bulbs? So S1 is closed, S3 is closed. So let's check out the electrical circuit. Yeah, okay, so this one is closed, so it will go here. So one bulb, two bulbs, and come back. So 1, 2. This is closed as well, so let's say there's a dry cell here. One bulb, two bulbs, come back. So light it up. So there is 4 bulbs. So given that all the bulbs are working, the maximum number is 4. Okay, so let's take a look. Mimic wants to add one more switch to the circuit such that only 2 bulbs will light up when all the switches are closed. Given that all the bulbs are working, draw a cross in the circuit diagram to show the position of the additional switch. So let's look at this. So let's analyze this. So this section and this section and this section are all in parallel. All right. This and these 2 bulbs are in series. So I know that if I want to add a switch, I need to switch off this one and this one, because then the parallel ones will still be lighted up. So then therefore I've decided to put a switch here which will open up, and let's see the electricity. So you'll come here and it will stop, and therefore these 2 are not lighted up. But this one has a battery as well. It will come here, it will go, because all switches are closed. So this will light up, this will light up, and then it will come back. Alright, so these 2 will be lighted up. So this is the position of my switch. So let's look at this question below. Lee Sing set up the circuit below. You have some batteries, you have a light bulb, you have some material. So again, once you see a material, you're testing for conductor or insulator. Alright, so that's a question that tests for conductor or insulator. She used different materials in the circuit and observed whether the bulb is lit up. She recorded her result. Material W, X, Y, Z. Did the bulb light up? Yes, yes, no, yes. So therefore, material W is a conductor. Material X is a conductor. Material Y is an insulator. Material Z is a conductor. What is the aim of the experiment? To find out if the materials are conductors or insulators. Okay, so that is the aim of this experiment. Alright, so let's look at the next part. Study the diagram below. You have again some batteries over here. You have a switch. You have a light bulb, switch number 2, light bulb, switch 3, switch 4. So the numbers 1 to 4 represent the locations where, not switch, it's where W, X, Y, Z can be placed. All the materials must be used, and each material can only be used once. In the table below, fill in where you can place materials W, X, Y, and Z such that the most number of bulbs will light up, the least number of bulbs will light up. So let's take a look. So basically, if I refer back to my material, I have 3 conductors, 1 conductor, 2 conductor, 3 conductor, and 1 insulator. So I need to decide where to place my insulator such that the most will light up. So I know I need to place them in a parallel circuit. So this light bulb and this group of light bulbs are in parallel. Alright, so there are 3 light bulbs here, so therefore I know I need to put the insulator here so that it will not affect the 3 light bulbs. Okay, so this will be the conductor, conductor, conductor. And let's take a look at how the electricity will be traveling. Okay, come. So this is the conductor. So if I have the insulator and I have the battery, so it stops here, it will carry on, go here, conductor, it will carry on, come here, it will carry on, come here, carry on, carry on, carry on, carry on. So therefore 1 light bulb, 2, 3, 4 are lit up. So let's fill in the answer. This is position 1. So position 1 is the insulator. Conductor, conductor, conductor. Let's go back and see what's my insulator. My insulator is Y. So therefore this is Y. and W, the others can just be any letter, W, X, and Z. And then use your correction tape and remove this away. Okay, so let's just check, make sure that my Y is my insulator. All right, that's correct. And WXZ can be in any order. Another location that I can put my Y is actually over here. So I'll put a insulator here. All right, conductor, conductor, conductor. So let's draw it out. So this is one light bulb, 2, so this is a stop here, 2, 3, and then come back here, 4. All right, so 4, 3, 2, 1. So that's also 4 light bulbs. So this is the other possible location for your insulator Y. So the next we need to look at the least number of bulbs will light up. And we know that because I want the least, I need to put the switch in series with my light bulb. So let's take a look at where are my series. So this is a parallel. This is also parallel. This is the only one in series with the batteries. So if I put my insulator here, conductor, 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 this is how it will go. So it will conductor, so this will light up, yes. So all go, and everything here will be stopped at this. So this will not light up, not light up, not light up, not light up. So this is the position for my insulator. And therefore position 2 is material Y. So material Y is position 2, so W, X, and Z. So the rest you can put in any order. So Lee Sing wanted to find whether the number of bulbs in a circuit would affect the brightness of M and N. Set up the following circuits to investigate. So there are some batteries here, 1 battery, 2 battery, 3 batteries, 1, 2, 3. So that's okay, same. 1 bulb, 2 bulb, 3 bulbs, 1 bulb, 2 bulb. There's a variable there. In parallel, these are in parallel, and this is in series. So there are 2 variables. So do you think Lee Sing will be able to achieve her aim? Nope, she will not be able to achieve her aim because there are 2 variables. One of them is the number of light bulbs, and the other one is the arrangement of the bulbs. So what she needs to do if she wants to find out if the number of bulbs in a circuit is she actually just choose only parallel. So use 3 bulbs for both circuits A and B, and 1 do parallel and 1 do series, and then after that see the brightness and see which is brighter. Okay, so Lee Sing set up 2 circuits, C and D, 2 more circuits. She increased the number of bulbs in each circuit and observed the brightness of the bulbs. She recorded the observation. So brightness of the bulbs decreased, brightness of the bulbs remained the same. So if it decreased, it must be in series, and if it remains the same, it must be in parallel. Okay, so this is based on the graph above. What is the arrangement? So this C is in series and D is in parallel. All right, so let me just draw out circuit C, 2 batteries, 2 light bulbs, comes back. Circuit D, 2 batteries, 1 light bulb, 2 light bulb. All right, so it will look like that. Okay, circuit C, circuit D. If I increase the number of light bulbs, and I increase the number of light bulbs over here. Okay, so this one will remain the same, and this one will be dimmer.